Solved problems. Tell of each occurrence of a variable in the below formula whether it is bound or free. This formula has three occurrences of a variable. The first two are x's and the third one is a y. The first occurrence of x is obviously bound because it is part of a quantifier, and so is the second because it is inside the quantified formula which starts with a quantifier there exists x. So the second occurrence of x is inside a formula of the form there exists x, a. But the occurrence of y, the only occurrence of y in this formula, is free. In fact, the formula has no quantifiers of the form there exists y or for all y, so it couldn't possibly be bound. Next problem. Tell of each occurrence of a variable in the below formula whether it is bound or free. So now we have here some x's and some z's. X has three occurrences and z has two. The formula starts with a quantifier for all x. In fact, this formula is of the form for all x, a. From this it follows that every occurrence of x in this formula must be bound. On the other hand, when we look at z, there is no quantifier of the form there exists z or for all z in this formula, so these occurrences of z couldn't possibly be bound, and indeed they are free. Next problem. Which of the following formulas are sentences? A sentence is a formula which has no free occurrence of any variable. The first formula is for all y there exists x such that x less than y. Both occurrences of y are bound by the first quantifier for all y, and both occurrences of x are bound by the quantifier there exists x. So this is a sentence. P0C or P0D. Well, this formula has no variables whatsoever, so certainly it has no free occurrences of variables. It is a sentence. The next sentence. For all y there exists x, left parenthesis, x less than y or x equals c, right parenthesis. The formula starts with for all y. Indeed, this formula is of the form for all y a. So every occurrence of the variable y in this formula is bound. The same is true of x. The quantifier there exists x binds the next two occurrences of the variable x. So both y and x only occur in bound occurrences. This is a sentence. The next sentence. For all y there exists x such that x less than y or x equals c. Now this is different because the second disjunct x equals c has x free, but all occurrences of y in this formula are bound. So the answer is the first three formulas are sentences, the last one has x free, and therefore it is a formula which is not a sentence.